In this unit, we begin with our idealized final solution and examine the real-life constraints which may prevent the idealized solution from being realized. By the end of the unit, you should be able to prioritize your final design solution using systematic design tools. In order to solve these problems, what we will call primary problems, we will use the theory of inventive problem solving, often referred to by its Russian acronym of TRIZ. At this stage, you should have at least some concept solutions, albeit ones which present problems in reducing to a working solution. These primary problems can usually be expressed as contradictions, that is, physical outcomes or results which contradict our idealized solution. As a simple non-medical example, let's consider the contradictions involved in building a faster motorcycle. A lighter motorcycle will go faster. However, a lighter motorcycle is unstable and potentially dangerous. So, our idealized solution of making the motorcycle lighter has a contradiction. By decreasing weight, the motorcycle is faster. However, decreasing weight reduces stability. So which is more important? In traditional engineering design, one solution prevails or a compromise between the two is found. TRIZ seeks to break the link between the two characteristics and enable both speed and stability to increase. In order to generalize the problem, we might say that changing a system parameter, such as weight, causes an improvement in a system characteristic, speed. However, this change in system parameter also causes poorer performance in a different characteristic, that is, in the motorcycle's stability. It is important to clearly understand the distinction between parameters, such as weight, material, color, shape and size, and characteristics such as speed, stability, power, performance and cost. Parameters are controllable. Characteristics are the result of the chosen parameters. Any change in system parameters will result in changes to system characteristics, which are either desired, undesired, or neutral. The approach of TRIZ seeks to break the contradiction or link between characteristics that are affected in different ways by improving a single parameter. TRIZ uses a tool called the contradiction matrix to break the contradiction or link between two confounding characteristics, for example, speed and stability in the case of the motorcycle. The contradiction matrix generalizes system characteristics in 40 categories. For each two characteristics which contradict when a single parameter is changed, the matrix provides a number of possible inventive solutions or principles. These inventive principles involve changing the parameters of the system in order to improve both the contradicting characteristics with a single action. For example, principle number 35 involves changing the physical state of the system. This is a principle applied to transfer nitrogen, oxygen, and other volatile gases over road. Principle 10 suggests preliminary action, such as buffering acidic solutions to avoid harmful effects. Principle 1 involves segmentation, breaking a large part into several smaller parts or steps for transport, assembly or convenience. Principle 28 proposes to use fields. One example is the reed switch, which uses magnetic fields to make electrical contacts and was widely used in the old telephone exchanges system. The original matrix, while effective, is a little unwieldy, and many online and offline tools provide the facility to automate the process of inventive principle determination. In the example with the motorcycle, improving the parameter of weight leads to a contradiction with the characteristic of stability. Altschul's matrix proposes 4 solutions to this contradiction: segmentation, physical or chemical properties, periodic action, and inert environment. Some of these are irrelevant to a mechanical system, for example, moving to an inert environment. Also, it should be noted that the contradiction matrix couples the parameter to improve with the undesired characteristic change and there is no input from the desired characteristic. So it is up to the user to see if the proposed principle then contradicts with the desired characteristic, in which case this principle should be clearly avoided or solved later. Problems that need to be solved later are what we call secondary problems. So, returning to our motorcycle, we could apply the principle of changing the physical characteristics of the motorcycle by using lightweight and hybrid materials which decrease weight without compromising stability. This is one elegant solution to the contradiction between decreasing the parameter of weight and the undesired outcome on the characteristic of stability. This simple generalized approach is one we can use to reduce from idealized solutions to concept designs, which do not contradict physical principles. The next difficulty is to prioritize the ideal solution. To do this, you will need to list all the characteristics of your specific system. While every system is different, characteristics such as cost, complexity, quality and time will occur frequently. You will need to work with your end users, your clinical champion and other key opinion leaders to weight each of your system's characteristics before applying that weighting to each concept design solution, which you generate with the help of the TRIZ matrix. This should give you a numerical score for each concept solution or design and enable you to make an informed quantitative decision as to which solution to prioritize. You may also choose to weight your end user scoring depending on how important you believe their opinion to be. At the end of this unit, you should be able to identify the contradictions within your proposed idealized solutions, apply Altshuler's contradiction matrix to resolve these contradictions, prioritize your idealized solutions to determine the optimal final design with the help of your clinical champion, and finally, reapply the contradiction matrix to resolve secondary problems in your prioritized solutions. Next time, we will look at refining our prioritized solution from a concept to a working design.